Welcome to kinematics lecture series. In this video we are going to see how to find out the direction of acceleration. Now if you have to draw an acceleration diagram when a mechanism is given to us, now we have to find out the direction of acceleration for all the different components. Now we'll see how we can do that using the following examples. Now we have to understand what is linear acceleration. Now it is the acceleration of an object making a linear motion. Now in this particular case, let's look at a vehicle which is traveling on a straight line. Now in the case when the vehicle is speeding up, when the vehicle is accelerating, now if you see, the acceleration will be the same direction as the velocity. So when the vehicle is traveling along a straight line, the velocity will be in the direction of the vehicle. So when the vehicle is speeding up, the acceleration will be in the same direction as the velocity. Now if somebody sitting in the vehicle has a cup of coffee, now which way will the coffee spill? If you see that, the coffee will spill in the direction opposite to the acceleration. Now we can visualize this. The second condition, the vehicle is traveling at constant velocity. So when the velocity is constant, acceleration is zero. So in this particular case, the velocity will be in the direction of the vehicle, but there will not be any acceleration. Now for this case, if you see which way the coffee will spill, the coffee will not spill in any direction because no external force is acting on it. The third condition, the vehicle is slowing down. So the vehicle is traveling, somebody is pressing the brake pedal. At that point, the vehicle will slow down. If you see, at that point, the acceleration will be acting in the direction opposite to that of the velocity. So now if you see which way the coffee will spill in that case, now it will spill in the direction opposite to the acceleration. So in that case, when somebody presses the brake, the coffee will spill forward. We can visualize that. Now in the next case, what will happen when the vehicle is traveling on a curved path? Now the vehicle is traveling, the road has a small curve. In that case, what are all the components of acceleration that we'll deal with? Now before that, we'll look at some basic terms. The first one is angular acceleration. This is the rate of change of angular velocity. Now we are familiar with the angular velocity omega. Now the rate of change of angular velocity is called angular acceleration. It's given by the symbol alpha. Now we have a tangential component of acceleration. So this tangential component of acceleration will be in line with the velocity. So this will be tangential to the curve. So in this particular case, it will be along this arrow, which is tangential to the curve on which the car is traveling. The next component of acceleration is the radial component of acceleration, now which is given by the formula r omega square. Now if we substitute the relation v is equal to r omega, we will get this as v square by r. Now if you see this, the radial component of acceleration is dependent on the velocity. It is velocity squared divided by the radius. Now having understood all these basic definitions, now let's look at the acceleration directions. Now we also have to find out which way the coffee will spill under different conditions. Okay, the first condition, the vehicle is traveling at constant velocity on a curved path. So this we can imagine the vehicle traveling at 40 kilometers per hour. Now without slowing down, we are traveling at the same velocity while going around this curve. In this case, the velocity will be in the direction of the car. The velocity will be pointing in the direction of the car. The tangential acceleration will be zero because the velocity is constant. So in the case of linear acceleration, the acceleration was zero. So here only the tangential component of acceleration is zero. The radial component is positive. Now it acts in the direction towards the center of the curve. So it acts in the radial direction pointing towards the center of the curve. So this is the direction of radial component of acceleration. So this component of acceleration will be there even when the velocity is constant. So if you're sitting in the car, if you have a cup of coffee with you, if the car is making a turn, then we will definitely be able to feel a force which actually pushes us towards the side. So in that case, if you see which way the coffee will spill, the coffee will spill in the direction opposite to the radial component of acceleration. So the coffee will spill outward. The next condition, the vehicle is accelerating on a curved path. So the vehicle is traveling, now the driver is pressing the accelerator pedal. So the vehicle is accelerating while it is traveling around the curve. So in that case, the tangential component of acceleration will be in the same direction as the velocity. But the radial component will still act towards the center of the curve. So the radial component of acceleration is also called the centripetal acceleration. So the centrifugal force is the opposite reaction of the centripetal force. So this acceleration corresponds to the centripetal force, which pulls the vehicle towards the center of the curve. So the opposite reaction is the direction in which the coffee spills. So in this case, if you see which way the coffee will spill, now we have two components of acceleration. So there is one tangential component, one radial component. So the resultant acceleration will be in a direction somewhere in the middle, depending on the magnitudes. So which way the coffee will spill? It will spill in the direction opposite to the resultant. So this is the direction. The next condition, let's look at the vehicle traveling along a curved path. The vehicle is decelerating. Now the vehicle is traveling along a curved path. The driver is pressing the brake pedal. Now in this case, the vehicle will slow down. At that point, the tangential component of acceleration will act opposite to the direction of velocity. So the vehicle is still traveling forward, so the velocity will be pointing in the forward direction. But since the vehicle is slowing down, since the vehicle is decelerating, the acceleration will be acting in the opposite direction of velocity. The radial component will still act in the same direction towards the center of the curve. The reason for that is the radial component is dependent on the velocity. It's v square by r. So velocity is still positive. So radial component is positive. It will act towards the center of the curve. So this is how we can find out directions depending on whether an object is accelerating or decelerating, whether it is traveling along a straight line or along a curved path. So using this logic, we'll be able to find out the directions of various acceleration components. Now in this case, which way the coffee will spill? So the resultant acceleration will be acting in a direction like this, in between these two components. So the coffee will spill towards this side. Now using this, we can find out whether a particular link is accelerating or decelerating, or whether the link is traveling along a straight line or along a curved path. And depending on whether it is speeding up or slowing down, we'll be able to find out the acceleration of the different links. Now we'll see how to do that in the next video. Thank you.